Mr. M presents Using Powers. Hi everybody. In this video we're going to take a look at how to use powers. Now, powers in real life can be hard to come by in some senses, but in the study of math and science technology you really need to know how to use them. So for example, some bacteria cells, like this guy here, divide themselves into two. It's called binary fission. So they break themselves down and they split into two new cells. Then those cells each break down and split themselves into two new cells as well. And what happens is every time they split, the amount of cells doubles. And what that ends up looking like in math is this: 2 times 2 times 2 times 2 times 2 times 2. And really, when you're talking about something like bacteria, that number can be absolutely gigantic, and that string of multiplying by 2 can go on forever. Well, I always tell my students, mathematicians are nothing if not efficient. So mathematicians have a way to show this giant number in a much more efficient manner. That's how we're going to use powers. So powers are the way that we can represent numbers like the one above in a very simple format comparatively. So basically it's pretty simple. If I'm multiplying 2 by itself 1, 2, 3, 4, 5, 6, 7 times, I'm going to write down the number 2, and then I'm going to put a small 7. That's the exponent. So what this number is saying is 2 to the power of 7. It's how a mathematician would take such a large group of numbers and bring them into something more small and manageable. Now, how do we solve this? Well, there's a few ways. A very legitimate way to do this is to use a calculator. If you learn how to use your calculator, you can literally punch in 2 to the power of 7. Usually it's with a button that looks something like an X and a Y or something like that. Depending on your calculator, it would be different. You can also do this by sort of looking at math that you know. 2 to the power of 7 means I'm multiplying 2 times 2 7 times. There's a big mistake we'll want to avoid, and I'll talk about that later, but let's just do this one properly. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So 2 to the power of 7 is 128. How did I do that? Well, I just kept doubling as I went. The whole point is that I should be able to move back and forth between these lists of numbers and my power in a way that I can solve it either one way or the other. A very common mistake that I see students make all the time when they're first getting used to using powers is that they confuse these two number sentences. Take a look. Very similar. You can understand why that confusion would happen. 2 times 2 times 2, 2 plus 2 plus 2. This number right here is actually the number we simplify by saying 2 times 3. You learned to do that when you were quite young. You looked at it and said, oh, that's 3 sets of 2. So it's 3 times 2 or 2 times 3, both the same, and that equals 6. But if you follow me here, 2 times 2 is 4, and then it's like 4 times 2 is my next number. 4 times 2 is not 6. 4 times 2 is 8. So basically I'm multiplying as I go. Eventually you'll kind of memorize some of these and they'll become a little easier for you to use, but when you're first getting used to them, just keep track of the multiplication in your head, or like I did here, jot it every few steps to make sure that you don't lose track. Let's take a look at this number so we can investigate a little further. 3 to the power of 4. It doesn't mean 3 times 4, which is 12. Let's make sure we keep that out of our heads. 3 to the power of 4 means 3 times 3 4 times. So, first thing I need to be able to do is to draw it out properly. 3 times 3 times 3 times 3. That's the same. Okay, 3 times 3 4 times. How can I solve this? Well, if you've got your calculator handy, you can use it. If you want to be able to do it in your head, then what you need to do is do it in steps. 3 times 3 is 9. Keep that in mind. 9 times 3 is 27. Keep that in mind. 27 times 3 equals 81. So basically I had to use my multiplication knowledge to help me. You can see why using your calculator is an attractive option if you get the chance to do it. Just a little pause to show you where you've been using exponents all along probably. Here's our measurement for area, meters squared. The squared means that I'm doing meters times meters, which if you keep track in your head is because when you're measuring a flat shape, you're measuring two sides and you're multiplying them together. So this side, meters times meters equals meters squared. For meters cubed, you're working with a three-dimensional shape, so you're measuring one side times a second side times a third side. So that's why you wind up with meters to the power of 3. Meters times meters times meters. Just a little reminder, you've been using them for a while, you just weren't considering them that way. Here's your chance to try a couple. Let's see if you can convert these from powers to number sentences, and then back, and then also solve the answer. Okay, I'll give you a second and we'll come back and solve them together. Okay, let's start with the top one. 8 times 8 times 8 times 8. That means that my base is going to be 8, and I've got 4 of them, so my number is going to be 8 to the power of 4. That also means that I'm doing 8 times 8 times 8 times 8. I'm going to use a calculator to do that. So that will be 8 times 8 times 8 times 8, and that's going to equal, big number, 4096. That's going to be the answer to that. 8 times 8 times 8 times 8. Down here on the bottom, this number, 5 squared. That means I've only got 2 of them, so I'm going to write this out. 5 times 5, and I shouldn't need a calculator for that at all. 5 times 5 equals 25, which means 5 squared equals 25. And I think the key about using exponents when you're first learning how to use them is to figure out when you need a calculator and when you can do it mentally. It's a waste of your time to do it on a calculator if you can quickly do it mentally in your head. And it's also problematic if you really try and stick it out and multiply it all in your head, even though it's a number that would be much easier to do on a calculator. For me, this number here is much easier to solve using a calculator. Down here, I was much faster using my head. The key is to consider which strategy is the right one for which exponent.